It's an absolute pleasure to introduce the next speaker. He's a professor emeritus at the School of Oceanography at the University of Washington in Seattle. He's had an eclectic career from prospecting for precious metals in Western United States to studying and living in volcanoes in the Galapagos Islands, to the career we all know him best for, a long and storied career in studying and exploring volcanically active seafloors in both the Atlantic and Pacific Oceans. He's internationally renowned as a researcher on the myriad oceanic processes operating in, above, and below the seafloor. And he's a staunch advocate for the potential of new technologies to revolutionize ocean research and science. Most recently, he's turned his attention to ocean cultural literacy, sharing with the general public a broad and interlinked spectrum of narratives about how human societies have used or been impacted by oceanic systems. And he's endeavoring to increase public awareness of the global ocean, which he calls the ultimate life support system on the planet. It is with great pleasure that I introduce John Delaney, and please give him a warm welcome.
This is a joy because Louis Fox, I won't just call him an old friend, but he's a good and long-term friend is a better way to put it. He's not old yet, but Louis has played a very significant role in a number of the things that I've tried to do. I want to mention also right at the outset my authors. I think Gary Green is here in the audience. I don't know if I can see him or not. There he is with the silver hairdo. And Dana Manalang is an outstanding engineer from the Applied Physics Lab at the University of Washington. Anna Sulk is a brilliant grad student that I've been working with for the last 5 years. And Hunter Hathaway is kind of the Michelangelo of graphics. From my point of view, he works for Scenic, and he pitched in and helped me with the graphics. So giving credit where credit is due. I wanted to mention to you that this is declared by the United Nations that this decade that we're in, from 2021 to 2030, is the decade of ocean science for sustainable development. And the topic I'm going to address with you today is more along the lines of how we can begin looking at sustainable elements that are linked to the ocean, but clearly centered on human beings. And the previous panel of brilliant people made it very clear, I think, that the insights that the New York Yankees catcher, Yogi Berra, the insight he had is truly applies to us at this moment. He said, the future ain't what it used to be. And surely after that session this morning, it's very clear that the future is rapidly changing. I want to also mention to you, I've been told that I have a somewhat offbeat sense of humor, so I want to warn you about that. But it's very clear to me, from my home state in Washington, which is beautiful with Mount Rainier and the like, I've got to tell you, the view today, this moment from this podium is absolutely scenic. It is just really, it's truly delightful. So I also want to make it very clear that I come to you not to, as many of the folks that give talks and the like are here to tell you things that they know and maybe you don't. That's not here for me now. What I'm coming here to you for, as I've known Louis and Scenic for a long time, and Leanne, I come for advice. I would like very much to have your evaluation of the things that I'm going to share with you. And both Gary and I would love to have your advice. So that's what we're here for. So the topic here the title is Sustainable Stewardship of Urban Sea Systems May Actually Be Feasible Using Digital Twins. And the obvious question for everybody would be, well, what's an urban sea? Well, here is a way of looking at it. These are the drainage basins in the North America, and there is the Salish Sea, and there's the definition. So I'll give you a second to read it because you can probably read faster than I can. But it's 3 key elements: the coastal watersheds, the marine part, and the big cities and the little cities in that drainage basin. Others you probably are aware of on the East Coast, and since we are here, you are part of you're in a drainage basin right now, and there are many of these. How many are them? Where are they? Well, here's a good example. Just not everybody sees maps and sees what I'm a geologist, sees. So I share with you this block diagram that shows the elements: the watershed, the port city, the marine sector, all the factors on, groundwater, weather, everything. So we'll come back to that in a minute. But where are these urban seas located? Okay, so, the Bay Area, it's not the heart and soul of everything, believe it or not. And here are about 200 plus urban sea systems that are dominated by the port itself. And why do I pull these together? Everybody knows this, basically. Well, they're all threatened by climate change, both big storms as well as sea level rise, which is coming. Make sure you know that. And it's going to, we don't know what the rate is going to be, but it's going to be serious within a couple decades. And I see that most of you are still going to be here after a couple decades. Some of you after, who knows? Ray Kurzweil plans to live forever. So, maybe some of you are going to do that as well. Good luck. But the other thing I want to make sure is, there's these big cities, these entire ecosystems of the urban sea system, they're bleeding pollutants. Where? Into the ocean and into the atmosphere. I'll come back and touch on that in a minute. So how does these are all part of the global trade network. And how does that network work? Actually, this group is not necessarily anyone to lecture about it. All I'm saying is sharing with you what I've learned lately. And we're talking about these ports. I just shared some of those with you. But we're also talking about the network infrastructure on the planet. The submarine fiber optic cables are the way in which the orders, the bills of lading, the money is transferred. Everything happens, in this case, globally, on the seafloor, underwater. And what happens on the top of water, we hope most of the time, is the ships that move back and forth, plying the oceans with massive amounts of material. Most of you are wearing something that came here on a ship. Most people get food from a ship that comes from somewhere else. And everything that moves across the planet creates a market, and that market makes these urban sea system port cities very, very wealthy. They make a lot of money. That's the first step. So where in North America, you're all probably familiar with what I'm about to show you. Again, keeping in mind that I'm here for advice, not to lecture. These are the made port cities, and you see Mexico is on here and Canada is on here. I've done my best. I did not get to the route through the Arctic. I didn't find a large port city up there yet, but I'm sure the time will come. And so these are the port cities. Here's the population centers. Here are the cables that come ashore in North America. These are the places where big trucks, I don't have the railroads, but the big trucks that move around the country, taking things from the port cities to the hinterland, are shown here. And here are a year's worth of ship traffic with regard to North America. So you can see it's a very dense activity. And the other thing you realize is when the trucks come to the ports or the trains come to the ports to pick up the material that comes off of a ship or to deliver material that goes out on a ship, they all burn diesel fuel, and so do the ships. So when the ships pile up in port for various reasons, or when the trucks have to stand around waiting, many times they're burning fossil fuels. This right now, these circles are sources of pollution. So it's important to realize what the scale of that we're talking about here in terms of finances. This is not small potatoes. Many of these global supply networks are vital to countless livelihoods. But look at what the global trade has been. This is not small potatoes. This is big potatoes. But the important point I'd like to make is that we are in a position now, and we have the desire and I think need. We certainly have the need. I don't know if we have the desire to make the environmental and social impacts of this economic activity much more carefully factored into the global economy. I mean, we have historically built what we needed to build and only secondarily thought about, well, what are the consequences environmentally, ecologically, human health, all of those things in the vicinity of big port cities are a serious issue. So here is just to synthesize what I have just said to you. These are what the urban sea systems are. They're global regional supply chain hubs. Therefore, wealth and materials flow through them all the time. They're hotspots of ocean atmosphere pollution, serious hotspots. And they're vulnerable to natural disaster and attack. Recognize that one of the very first things that happened to the folks in Ukraine was that Mariupol was tried to be taken over by Russia on the Azov Sea. The Black Sea, of course, is a focus for a lot of difficult things. It's an urban sea. The Baltic is Gary Green in the audience here is one of the specialists here on the Baltic, 8 countries, one of which is Russia. They're very, very worried about what can happen in their sea. And it has, in the past, had significant problems with pollution, as have places like the Chesapeake. They're also hosts for entrenched inequality. I'll touch on that in a minute, but entrenched inequality has to do with the well-being of the people that live there and their health. We'll touch on that. So we must find a way, because of the power of these places, we must find a way to preserve and maybe encourage and develop the economic vitality, but to mitigate the ecological decline. We've got to stop the decline. It's more and more serious as we stand here talking. And we have to address the homeland security. That's a whole topic in itself. I am not qualified by the U.S. Navy to speak to you candidly about that, and probably no one in the room is. But there are many facets. But a big earthquake here or in Seattle, magnitude 9 is imminent, or for that matter, giant storms, or even not such giant storms. California has certainly received its share of water from heaven. So any number of things can affect the peacefulness, I suppose. I'm not sure I'd put it security, but the homeland has to be protected from both natural and unnatural issues. And finally, social justice and population health are key issues that have to be dealt with and probably should be dealt. All these should be dealt with by folks who are from the area itself. You wouldn't want the people from Chesapeake Bay coming out here and telling you, okay, listen, here's what you should do with the Bay Area. nor would you want folks coming from the Salish Sea and going to Galveston and say, look, you guys in Texas need to understand how, that's not the way to go with it. So we have a challenge of how to work together and not try to use our elbows too sharply. So the hotspots of ocean pollution, just as an example, here's where the plastics are. And we know about the plastics because they're very recognizable. And that's not really what I'm talking about so much here today. Here's what I'm asking. What else is accumulating in addition to all that plastic that is not so readily recognizable? What else is the ocean absorbing? Among the things it's absorbing are a wide variety of trace elements, not the least of which is mercury in the various animals, creatures, and the food web in the ocean gradually builds up to the time when you have larger fish, which have concentrated. It's called bioaccumulation, and it's a serious issue. We all eat things now, for instance, that have even microplastics in them. We all have microplastics and nanoplastics in us. A question I pose is, can the environmental impacts of urban sea systems be quantified? Do we have any idea what the overall bleed rate of noxious materials from all of the 200 urban seas into the global ocean, which is, it's no longer infinite. We used to think it was, but, dilution is no longer the solution. So we need to begin quantifying it. And who's responsible for doing that? It's offshore, don't worry about it. And then the inequity. Here's a perfect example, and this is not isolated. This is Mumbai and the slum and high-rise sectors. It's a dramatic contrast of many, many people living, and all these little blue shacks are right within about a meter of sea level. And the people that are there have almost no assets, and they will not be able to stay there once they're flooded out by either big storms or, in addition, sooner or later, sea level rise. So what happens? There may be as many as 500 million to 1 billion people living in similar areas all over the world. And we're blithely going along and doing our thing. We've got to plan for this, or we're going to have a refugee problem on the planet that dwarfs what people think we have now. Because these people have no place to go, and they're going to have to go somewhere. So it's a potent refugee problem within decades. So if we're to learn how to wisely manage these urban sea systems, we have to figure out how to understand their complexity. And trust me, they are a study in complexity. So digital twins may be a path forward, and probably most of you know about digital twins. They are, what is one? That's a picture on the right, which shows partly of a real city and partly imagined city. But they're computational renderings of real world systems based on historical data. That's very important. But even more important is real-time data. What these digital twins can do is this. They can allow scenario building or what if questions to be asked by many different kinds of users. These are not normal models, which are usually for other modelers. These are for people who want to manage, want to work, want to figure out what to do next. And they offer, because of the real-time data, they offer up-to-date visualization of all the process interactions. So imagine being a mayor or a governor and wanting to know what steps you want to take in order to solve some problem. And unless you have access to this type of capability, you'd be worried about that problem and the people that are involved. What you really need to do is balance all of the factors and all the people that might be impacted by what you're talking about. Okay, so a colleague of mine, Martin Visbeck from Kiel, Germany, has put out this proposal to, Sorry about that. About creating digital twins of the ocean. And I want you to let your eye drift around your periphery of this oval, the sensor data, models, visualization, insights, decisions to be made, interventions, and then, look at the outcomes. So one point is historical and real-time data have to go into the system to begin with. It's going to take a while to put these things together. But once you have a model that operates like this, you can play with time. You can actually look back at events that took place and look at all the factors that were involved and evaluate whether going forward, which you can then turn with a model, you can turn and go forward as well. Imagine those things happening and how would you react? So they also, because of what I just said, they improve significantly with time. So let's set that one aside. That's pretty good for oceans. But then let's talk about what possibilities there might be for digital twins for urban sea systems. Well, it could be the Chesapeake, it could be San Francisco Bay, it could be Salish Sea, it could be any number of these. And I will proudly say that we share the Salish Sea with the folks from Canary and Canada, and they are delightful to work with, by the way. And we look forward to those kinds of collaborations, but it's state to state and international collaborations when it comes to these kinds of systems. So what are the processes involved? There are 3 of them. I won't dwell on that. I can already feel the end trying to push me in time. So I just point out to you that every single urban sea system is unique. We're not coming up with one model that fits all. No, it'll never happen. In fact, every one of them is going to have a model that is crafted, designed, and built in conference with the experts that are local and maybe with help from groups like Scenic, and maybe groups like Lawrence Livermore Labs, places like that. These are both national security as well as the well-being of people. So they're a study in complexity. Well, what do we mean by that? Like all complex systems, they have many, many interacting processes, and it's very difficult to be predictive in that regard. But you need to start with modules, what I would call modules. The individual activities will have, the individual sector is going to have activities in them that all interact, and then the sectors are going to interact. And then ultimately what you want is a system that describes the entire thing, the entire drainage basin and the cities and the marine part. So back to our favorite little diagram. This is a short course in geology. But there you are. Those are the kinds of processes that we're talking about. And here you can say that each of the processes that we will talk about can be modeled as a digital twin it'll be a subcomponent module of the overall model. And you have to start at that level. So here are the kinds of things: weather, socioeconomic, hydrodynamic, water quality, ecological, the entire ecology, and the economy, and how humans make decisions and how they move and vote. Where do the indigenous people have rights that have been ignored? We have to look at all these things. They all come together. And it's by trying to quantify how our societies function, particularly on the shorelines of the continents and particularly at the edge of the ocean. This is where it's worth paying attention. So here is a paper that was published by my colleague, Catherine Soboshinsky, a year and a half ago, and it shows a cartoon-like thing. You can take a look at these. All these slides will be made available to any of you who are interested. And I just went down the list on that cartoon and identified what a number of the subsystems could look like that would become modules. And someone else could come up with 6 or 8 more, or get rid of some of the ones I have here. There's a special one, which is real-time data, and I include that here. But then if the bottom line here is that these are going to interact with one another. They're characterized by a digital twin module. There are the same 16 that I just listed, but they're now crafted. We worked overtime. I'm joking. This is where we need to go and begin making modules that are interactive modules from experts that know about these particular issues. And they will interact with one another, and ultimately the system will have all of them interacting. So we need domain experts, very crucially. Some of them do work in silos, and somehow we're going to have to get around the silo sense that many of us have. I mean, I'm guilty of it myself. Across the board, collaboration is crucial. And so we have to break the silos and begin interacting with one another, possibly through a cloud, almost certainly eventually through a cloud. And this is the kind of thing that we would see. And in pursuit of something that deals with any urban sea that you can name. There are, as I said, over 200 of them. And let's follow this real-time thing, because that's kind of an innovative technological and investment and data flow issue. But this is all 16 of them again, and they're all going to eventually reside in the cloud somehow, somewhere for that particular place. And here is a rendering of what a system like that might look like. And my colleague, Dana Manalang, one of the authors, points out that we do have resident vehicles that can sort of live in the neighborhood. They can be underwater, they can be on the water, they can be above the water, they can be above the land. And these vehicles can send data either ashore or to a node, and they can receive mission tasking directly at any point from pilots. And these are the kinds of things you would imagine. And here is the bottom conclusion of this particular slide, that we will have fixed and mobile autonomous sensing platforms that are basically surface, aerial, and subsea, and they're conveying real-time data of all the things that the modelers say we really need in order to make sure the model works well. That's what we will have to do. So to reiterate this point, weather data, watershed data, city data, ocean data, all come to a cloud-based hub, and they're in the local neighborhood. There will have to be, by local, I mean in the Bay Area drainage system, or Salish or Chesapeake, digital twin modeling center. And probably we need national ones so that we can begin have people solving problems that can't be easily handled on the local level. But now I'm beating a dead horse, not a dead horse, a horse I'm hoping to bring alive. Bad phrase. No. Yeah, I'm almost through here. So these are the interactions that we're talking about. And I bring your attention to the note in the lower left-hand corner. And the last couple slides here is the urban simulation of a digital twin framework allows you to look at the real-time data with data inputs, modeling, looking at the modeling, and looking at rendering of the modeling and visualization, make your decisions, and then make an intervention. In the lower left, I show the removal of the Elwha Dam about 3 or 4 years ago. And then you look at the entire system on the far left to see how the effect of what the intervention has been. And the intervention could be anything. Okay, so I leave you with this then as the final, nearly final page. Leanne, please be generous here. Oh, well, I have another 140 slides. Every urban sea system is unique and complex, but all face similar issues. And here's a point I haven't made earlier very well, but progress within urban sea systems would also serve significantly as progress toward alleviating many of the impacts of climate change. Impacts both environmental, but also on the populations, because most of the human race lives within these urban sea systems once you take into account the drainage basin. So here's my conclusion, that a comprehensive, interactive international effort to optimize stewardship of all urban sea systems would benefit most of humanity. My question to you, I come asking advice, does this make sense? Is it doable? And would a group like Scenic and others like them, other NRENs, I forget the term, would they be central to it? We're not exactly starting from scratch. There's a great deal of historical data that already exists and is accessible. Not all of it is accessible, and there are people who don't want their data to be used. So there are issues. There are some excellent examples. Think back, those of you who can, for 45 years to what the capacity to predict weather was in the 50s and 60s. It's not, it's much better now. And the best example of that is there are modelers all over the country, all over the world who model the movement of hurricanes. And it used to be that the paths would go all over the place. Now, when you look at the ensemble, they're fairly tight, fairly nice, but they're all different models. So there's no single model that's going to dominate anything. So we have to address, while we're doing this, we have to look at the technologies, the levels of activity, and the standards that are going to be required for collecting and sharing real-time data. That's a challenge. We have to aggressively work on a few well-studied systems while seeking agreement on the principles, approaches, and collaborations. This would be mounting a major effort. Once a digital twin approach is established, however, it doesn't make sense to say, oh, that's 5 years, let's quit. Once you start, it's like scenic. Scenic isn't going to just stop someday. It's going to continue. It's going to expand. It's going to get better. The same with Canary. The same with in Cootie. It's going to be a long-term investment for the entire community that's involved. So I bring you back to the initial comment that I made by a very wise gentleman who worked for the New York Yankees. And the future ain't what it used to be. And it ain't going to continue to be what it ain't. I don't quote that. So that's it. Thank you very much.